Alright, so the next topic we're going to be covering is vector components. So to break a vector down into its components, we're going to first need to define a coordinate system. The most standard coordinate system is the Cartesian coordinate system, or otherwise known as the rectangular coordinate system. The diagram below shows the Cartesian coordinate system. We can see there's an x and y axis. So now that we define the coordinate system, we can now look at a vector A under this coordinate system and break it down into its components. So for the Cartesian coordinate system, the A vector can be broken down to the AX and AY. So below shows how we can break A into AX and AY. We can see that there's an AX vector going in the X direction, and we can see there's an AY vector going in the Y direction. With the magnitude of A and the angle theta, we can now find the values of AX and AY using trig identities. So AX is going to be equal to A cos theta, because cos theta is equal to adjacent over hypotenuse, and it's equal to AX over A. Because if we look at the diagram, theta, the adjacent vector is the AX vector, and then the hypotenuse is obviously A. And then for the AY, we can see that it would be equal to A sine theta, because sine theta is opposite of hypotenuse. And if we look at the diagram, opposite to theta is the AY vector. And if it's not completely clear how we got that, below shows how we got it. So basically, when we got cos theta is equal to AX over A, we can just bring A to the other side to isolate for AX. And so that's how AX is equal to A cos theta. And you can do the same thing for the sine theta equals AY over A. We can bring A to the other side and isolate for AY, and that's how we get AY is equal to A sine theta. So that's basically everything you need to know about components. Now we can bring this into an example question, which we'll see in the future.